Here's our remainder theorem video. So the remainder theorem, we're going to come down here and we're going to go through the definition and then go back up. The remainder theorem says that p of x, some polynomial, divided by a factor x minus a, produces a remainder equal to f of a. So what does that mean? It's kind of a little fishy at first. So here's our polynomial. We'll call this the polynomial p of x. And it has a root here, and it has a root here. So it has double roots and a single root. So we have a root at -4, 0, and a root at 2, 0. We're just going to put times 2 because there's 2 of them. You wouldn't normally need to write that. It's just for you to remember. So here's our function. So if I took x minus 2 squared over x plus 4, and I divided it by one of our factors, like x plus 4, I could do that longhand, or I could just use fractions to see that it cleanly divides out, no remainder. X minus 2 squared, no remainder. Or you could also say that the remainder is 0. So if I were to plug in -4 into this function, I would get out a 0, which would be equal to the remainder here. So that's what the remainder, this theorem is saying. So if you plug in an x into f of x, the output y will be the same as the remainder for the division of f of x. I'm actually going to come back up here. Plug in a, we're going to call it a, but this a is an x value. So if you plug in an a, which is some x value, into f of x, the output, the y value, will be the same as the remainder for the division of f of x divided by the factor that would be created by x minus the a that you plugged in. So that a and that a would be the same number. Okay? So who cares? If there is a polynomial p of x and I'm interested in whether or not it is a linear factor, if it's a root of our original function, instead of long division, which has got to sound like a breath of relief, instead of long division, I can instead plug in a into the function. If the remainder is 0, which is the same as if the output is 0. So this output of 0 means that if I had divided it, I would have got a remainder of 0. Then x minus a is a factor. So let's apply it here. So got this function, and x minus 1 is a root of f of x. Let's come over here a little. All right, that's a little better. So here's a polynomial, and we want to know, is x minus 1 a root of f of x? So in other words, we're asking, is x plus 1 a factor? So we could do what we were doing before, which is take and divide this whole long thing, f of x, by x plus 1, but that is not fun. We've all done that plenty now. Instead, we're going to do f of negative 1. We're going to take 3 times negative 1 cubed plus 2 times negative 1 squared plus 1. This is going to make negative 3. This is going to make positive 2, and that's going to be positive 1, which means the answer is 0. So f of negative 1 equals 0, which means it's a root. Visually, it should make sense that this, when I plug in a number, negative 1, and I get out a 0, should be a root, because roots, let's shift this up here a little, roots are where it touches the y-axis. So this does something like that. Okay. If we wanted to, we could do long division to find the remaining 2 roots, but for when we do, things to remember. We're going to do something next week called P over Q rule. Sometimes it's called the quotient rule, but when we're doing the P over Q rule, use remainder theorem to check if a value x produces a 0 y. Like this one.